There are many types of resistors. Carbon film resistors are made using high-temperature vacuum coating technology. Carbon is obtained by high-temperature decomposition of hydrocarbons and deposited on the magnetic rod body. We can control the resistor structure by changing the thickness of the carbon film or by etching. Anti-film resistor has a great cost-performance ratio. It is often used in mid to low-range consumer electronics. Metal film resistors are also a type of patterned resistor. The difference between them and carbon film resistors lies in the material used. Metal film resistors use materials such as nickel-chromium alloys. However, its performance is greatly improved compared to carbon film resistors. Its temperature coefficient and voltage coefficient are better than those of carbon film resistors. Therefore, metal film resistors are often used as precision and high-stability resistors. Metal oxide film resistors are also a type of pattern resistor. The resistor material for them is a metal salt solution. Their manufacturing method is the same as the first two types of resistors. Their resistance film is thicker and more consistent. Flame resistant. Metal oxide film resistors have excellent pulse performance. Their high frequency and overload performance is often used in medium to high-end electronic products. The composite film resistor is made by mixing carbon powder, graphite, and fillers into a suspension with an organic adhesive and coating it on an insulating tube frame, formed by high-temperature polymerization. For example, the moisture resistance and stability of the synthesized film cement resistor and synthesized film resistor are relatively poor. Not good for making resistors, but often in high-voltage apps. Wire-wound resistors are made by winding alloy wires around a magnetic tube in order to prevent moisture and avoid coil looseness. It is protected by an outer layer covering for protection. Has low noise, good linearity, good thermal stability, high accuracy, and can work at temperatures of over 300 degrees Celsius. Commonly used in high power, high precision, and high temp environments. Alloy foil resistor. It is made by bonding an alloy foil on a glass substrate. A pattern can be recognized with photolithography. An epoxy resin layer is then applied as a protective coating, and it is assembled with lead packaging. It has high precision and high stability, and can maintain a minimum temperature coefficient over a wide temperature range. The accuracy can reach 0.001%, making up for the shortcomings of metal film resistors and wire-wound resistors. Of course, its price is also tens to hundreds of times higher than the former. Organic resistors mix conductive carbon graphite with non-conductive particles, like mica or quartz, which are then formed by heating and pressing. Its characteristic is strong overload capacity. It will not short-circuit under harsh environments and overload conditions. So it is often used in high-precision situations. Glass glaze resistors are made by using glass as a binder, mixing old metal oxides, and then using a printing sintering process. Form a resistor film on the ceramic substrate. Its resistor film thickness is much thicker than the thickness of ordinary resistor films. Glass enamel resistors have high temperature resistance, low temperature coefficient, good moisture resistance. Commonly used in high resistance and low temp coefficient scenarios. The chip resistor we commonly use is one type of glass enamel resistor.